Okay, so for our last problem today, we have this problem. It all comes falling down. A block of mass m is 4 kilograms is attached to a spring of force constant K is 32 newtons per meter by a rope that hangs over a pulley of mass m equals 8 kilograms and radius r is 5 cm as shown. Treat the pulley as a solid homogeneous disk wherein the moment of inertia I about its center of mass is 1 of mr squared. We assume that the friction at the axis of the pulley is negligible. The system starts from rest with the spring at its natural length, and the rope does not slip on the pulley. So first, what is the speed of the block after it falls 1 meter, and what is the maximum extension of the spring? So yun yung kailangan nating hanapin. Observe una, ang tinatanong sa first problem ay speed. Ang tinatanong sa first problem ay speed. Therefore, ano kailangan natin gagamitin approach dito? Ano approach na gamitin natin? What we will be using in this approach is energy approach. Kasi obvious naman na sa spring, hindi mo masasolve using forces pag may spring. Medyo mahirap yan. Yeah, we will deal with the forces on a spring when we go to periodic motion. Pero for now, hindi natin kayang isolve yung equations of motion halimbawa pag may spring. Okay? So, ang kailangan natin gawin dito is use energy methods. Okay. Question so far. So, I'll just show you the solution to this problem. Okay? Sige. Okay, so paano natin i-solve itong problem to? So, again, we will be using energy approach. So, remember, when we deal with energies or momenta, what we have is, dapat meron tayong initial state at saka final state. So, let's say you have initial state. State 1 is that, I'll just draw the problem. So, I'll just draw the system. So, let's say, meron akong box edge dito. Tapos, originally, yung spring ay nakakabit dito. Tapos, hindi pa yan stretch. Tapos, okay, just like this one. Tapos, may pulley ako. Tapos, ayan. And then, after that, it is connected to some mass. So, let's say, small m. By the way, the height is not correct. Dapat ito ay magkalapit, just like this. So, yan. So, para siyang ganyan. So, capital M is the mass of the pulley, small m is the mass of the box. Now, syempre, hindi stable yung system na yan. What will happen is this mass will fall down and this is spring here will stretch at a certain distance. And after 1 meter, this is what will happen in the system. So, meron akong agad box dito. Tapos meron akong, this is the wall. Tapos humaba na yung spring. Tapos, this pulley here, and then what happened is this box here falls down at the height of 1 meter. Ganyan yung nangyari dun sa system. So, therefore, what happens is this pulley here will have an angular velocity omega, and then this box here will have some velocity v. Kasi hindi naman sinasabi sa problem na maximum extension na ng spring yung nangyari. That is, hihinto na yung box. So, ang tinatanong lang at this certain height, what is the velocity or what is the speed of the block? Yun lang naman yung tinatanong. Okay? And therefore, we expect that at that certain position, 1 meter, what we expect is that there is still angular velocity on the pulley, and there is a linear velocity of the box. Okay, so that's what the situation is. So okay, again we use since there are no frictional forces. Acting on the system, we use conservation of mechanical energy. That is E1, the total mechanical energy at state 1 is equal to the total mechanical energy at state 2. And from that, ang lalabas ay, remember, since the pulley is now rotating, so we need to express also the rotational kinetic energy of the pulley in other than the linear kinetic energy or translational kinetic energy of the box and the potential energies of the spring and due to the height. So we have gravitational potential energy and elastic potential energy in action. So dapat in each side of the equation, meron ka dapat na terms. First is, so let's write it. So we have the translational velocity translational kinetic energy of the box plus the rotational kinetic energy of the pulley initially, plus the initial position, or I should say initial potential, gravitational potential energy of the system, plus the elastic potential energy of the spring is equal to their final counterpart. So we have 1/2 mv2 squared, representing the final translational kinetic energy of the box, plus the final rotational kinetic energy, of the spring, of the pulley, and then we have final gravitational potential energy of the box, and the final expansion of spring. So there is some final elastic potential energy on the spring. So meron kang apat na terms. Now let's analyze. So initially, the height of the box is almost at the same height as that of the spring. And for state 1, it's easier if we set this height here, the given height, to be that height y equals 0. So we will set the initial heights of the system to be y equals 0. And then, therefore, the final height should be negative because what we have is the box is lowered to a certain height, which is y equals 1/3. And thus, what we have here is that, what can we say about the initial kinetic energy of the box? Is the box moving initially? Obviously, it's not moving initially, therefore, this term here should be 0. And then what can we say about the pulley? Is it rotating at the initial state? Is it already rotating at the initial state? Hindi nangyayari yon. Therefore, we also set this term here to be 0 because the pulley is not rotating. And then, since we set y equals 0 at the initial height of the box, we say that this is also 0. And then, since the spring is not stretching at the initial state, the spring does not stretch on the initial state, we say that this is also equal to 0. Therefore, the left-hand side of the equation is 0. So 0 na to. This is then equal to, let's say, 1/2 mv2 squared plus 1/2 I omega 2 squared plus mgy. This shouldn't be y1, this should be y2, mgy2 plus 1/2 k x2 squared. Now, observe that whatever kung saan man, paano man bumagsak tong first box na to, what happens, this is also the total length of the stretch of the spring. Diba? Syempre, babagsak ng box. Dapat, since the rope is stout, kung gaano kalaki yung bagsak nung box, ganun din dapat yung motion or yung pag-stretch ng spring. So, therefore, we see that since the stretch of the spring is equal to the distance traveled by the box, we see that xy2 is equal to x2. And hence, from here, we see that we can simplify this as 0 equals 1/2 m v2 squared plus 1/2 I omega 2 squared plus mg, I'll just write x2 as y2, so plus 1 mgy2 plus 1/2 k y squared. So I'll just write this as equation 1. I'll just write this as equation 2. And then from that, now we have now expressions. So for an expression for given in equation 2. The question now is this. I have my linear velocity here and I have my angular velocity here. So there are two unknowns in one equation. Therefore, we cannot solve it uniquely. We need another equation to solve for equation 2, to determine a unique solution for equation 2. Therefore, how do we know that second equation? Recall that the rope does not slip in the pulley. The rope does not slip on the pulley. And hence, Since the rope does not slip on the pulley, the radial, or I should say the linear and angular velocities should be related to each other by saying that V, hence, we see that the tangential velocity acting on the edge of the pulley is equal to the radius of the pulley times the angular velocity of the pulley omega. And hence, the velocity of the rope and therefore the velocity of the box should be related to the angular velocity of the pulley given by equation 3. Therefore, we now have two equations and two unknowns, and hence what we can do here is to determine V uniquely. So solving for omega in 3, we have omega equals V over R. So this is equation 4. And then what I will do is to substitute equation 4 to equation 2. So substituting equation 4 to equation 2, we have this. 0 is 1/2 m v2 squared plus 1/2 I multiplied by v over R quantity squared plus mg y2 plus 1/2 k y2 squared. So let's say this is equation 5. Medyo pangit ito. So let's call it mgy2. Yan. Okay. Now, recall that the moment of inertia for a uniform solid disk is ICM is 1/2 m r squared. So this is equation 6. And then I substitute equation 6 to equation 5. We have 0 again is equal to 1/2 m v2 squared plus 1/2 multiplied by 1/2 capital M R squared, where capital M is again the mass of the disk or the pulley, M R squared times V squared, or I should say this should be V2 squared over R squared, so the R squared will cancel now, plus MGY2 plus 1/2 K y2 squared. So this is equation 7. And I can transfer these last two terms in equation 7 to the left-hand side of the equation and say that this implies I have a minus mgy2 minus 1/2 k y2 squared equals a 1/4 m v2 squared plus 1/4 capital M v2 squared. So this is equation 8. Again, our objective is to determine the final velocity of the box. So I can isolate V2 in the right-hand side of the equation and say that this means that you have a minus mgy2 minus 1/2 k y2 squared is equal to V2 squared multiplied by 1/2 small m plus 1/4 capital M. So this is equation 9. And thus, solving for V2, we get this expression V2 is just a large expression minus mgy2 minus 1/2 k y2 squared all over 1/2 m plus 1/4 capital M raised to 1/2. So this is our expression for the velocity that we need. Okay. Now, what are the given quantities? Remember, y2 here, we haven't given any sign for y2. So y2 here should be negative 1.00 meters because, again, what we have here is we placed the box is lowered from its original position, therefore the height should be negative. And then K, given in the problem, K is 32 newtons per meter. Small m is, what's small m? I forgot small m. So let me look at it. So small m is 4 kilograms, while capital M is 8 kilograms. And there, so there you have it. So again, small m is 4, capital M is 8. So we have small m is 4 kilograms, and then capital M is 8 kilograms. And the given numbers are y2 is negative 1 meter. Again, it's negative because what we have here is that the box is lowered from its initial height y equals 0. Therefore, the displacement should be negative. And K is 32 newtons per meter. The small mass, the mass of the box is 4 kilograms, while the mass of the pulley is 8 kilograms. And then from that, we can see that the final velocity V2 is about 2.41 meters per second. This is the final expression for the final velocity. And okay, so we're done with the first problem. 2.41 meters per second yung sagot. For letter B, what is the maximum stretch of the spring? So the maximum stretch of the spring, it just means that the box already stopped moving until it rebounds. So magre-rebound yan eh, so maaatras yan. So what happens is, at this state, ang tinatanong ngayon, ano yung magiging height ng box such that, so again, if this is the pulley and this is the compression of the springs and this is the pulley, and this is the height, what is this distance here such that, of course, this is your y here, such that the mass now is at rest. Kasi nga, gusto mo maximum compression. Maximum stretch. Therefore, dapat hindi na dapat magkaano yan, gagalaw yan. Hence, dapat yung angular velocity is 0 and the linear velocity in this state is also 0. And then, this is now our third state. Let's say this is state 3. The state 1 is still the same as of the previous sub-problem. Therefore, I just write this as E1 equals E3. But we know that the total energy initially is 0. We know that. We know that already. And say that, okay, this is just 0 equals 1/2 capital M. Sorry, it should be small. Small m V3 squared plus 1/2 I omega 3 squared plus mg y3 plus 1/2 kx3 squared. These are the four expressions. But again, since we are now on the maximum compression, there should be no translational kinetic energy. There should also be no rotational kinetic energy. So this should be 0, and this should also be 0, showing that this is just equal to mg y3 equals negative 1/2 kx3 squared. Okay, instead of writing it that way, I'll just retain this expression here. Now, we know that the compression of the spring is equal, or I should say the stretch of the spring is equal to the total height that is the total height reached by the box. So this means that now we have y3 is equal to x3, and say that, okay, we just have mg y3 plus 1/2 k y3 squared equals 0. So we can solve this quadratic equation. I'll factor out my y3, saying that you have y3 multiplied by mg plus 1/2 k y3 is equal to 0. And thus, the first equation is that y3 equals 0. It means that it is the initial state of the box. So of course, at the initial state, there is no kinetic or potential energies. And there is no kinetic energy that is rotational or translational. So wala talagang gagalaw dyan. And hence, this is not what we want. What we want is some finite non-zero length such that there is no final translational kinetic energy and final rotational kinetic energy. And you have mg plus 1/2 k y3 equals 0. And thus, from here, we solve for y3. y3 equals minus 2 mg over k. So if we substitute the numbers that we have, what we have here is that this should be negative 2.45 meters, and this is y3. Therefore, the maximum stretch of the spring is 2.45 meters. That is the final answer. May tanong? May tanong ba rito? Are there any questions for this problem? May tanong? Kung walang tanong, thank you very much for this item.